Hi guys, welcome to the next lecture. Today I'm going to carry forward the basic stuff that we were talking about yesterday. I was talking about circles when we ended yesterday's lecture. So coming back to circles, a circle, as I said yesterday, it's the locus of a point which moves in a plane so that its distance from a fixed point in the plane is always the same. Okay, so this distance, which is your radius, it's always the radius remains the same. Okay, P is a moving point and the constant distance is your radius, and from the center we are looking at. So what's the equation of a circle? Equation of a circle is that the distance is the same. So using the distance formula, you can create this equation of the circle. Suppose the center is h comma k and this point P is x comma y on the plane, then the distance between these 2 points is fixed no matter what xy takes the value. For any xy, you have that x minus h square plus y minus k square is equal to r square, keeping in mind the distance formula. So r is equal to the square root of x minus h square plus y minus k square. So when you will square on both the sides, this is what you will get. And this is happening for all x, y, which are satisfying this equation. Okay. Now you can also think in terms of parametric form. Now, what is a parametric form? Parametric form is where sine theta, cos theta, angle comes into consideration. So suppose C is your center, and for from understanding point of view, I'm taking the center as 0, 0, so that the situation for us simplifies and the circle becomes x square plus y square is equal to whatever your radius is, r square. So suppose C is the center 0, 0, A is the radius, P is the point on the circle, which is x comma y. Those are the coordinates of P. If you construct, say, a perpendicular, which is cutting the x-axis at M, and then look at PCM, this is a right angle triangle. PMC, it's a right angle triangle, where you can easily see that CM, since this point is x comma y, so CM is the x-axis value, so it is x, and PM is the y-axis value at this point, so that's y. Now, sine theta, we all know, if we have a right angle triangle, this much trigonometry we should know. Sine theta is equal to perpendicular upon hypotenuse. Now, perpendicular length is PM upon hypotenuse, which is your radius A. So what can I say about PM or y? This implies y is equal to A times sine theta. This is a parametric form coordinate. Similarly, cos theta is base upon hypotenuse, so it will be CM upon A, which means that x is equal to A cos theta. So your coordinates x and y could be written as A cos theta, comma, y could be written as A sine theta. This is what is xy in parametric form. A general equation for a circle is x minus h square plus y minus k square equals to a square. Hk is the center. Or if you open this up, you will get x square plus h square minus 2hx plus y square plus k square minus 2ky minus a square equals to 0, taking everything to one side. And then what I've done is I've taken x square, y square here, then term with x, term with y here. And this is your constant term, right? Which is basically of the form x square plus y square plus 2gx plus 2fy plus c equals to 0. So say this is 1, this is number 2. If you solve the 2, what you will get that h is, if I keep this as my general form, I can say that h actually is minus g and k actually is minus f. Okay. A is square root of, it's the radius, A is the square root of g square plus f square minus c. So g square plus f square should be greater than or equal to c. That becomes a general condition for square root. Okay. Now center, that means is minus g comma minus f. Radius is square root of g square, square root of g square plus f square minus c. Now, how to find center and radius? Let me give you a couple of steps which you can always use, and then we will move on to an application also. Make coefficients of x square, y square equal to 1. That is, if you have, say, 2 with x square, y square, you can just divide throughout, okay? And the right-hand side equal to 0. So take everything to one side. With that, you'll be able to relate. So your center HK is nothing else but, if you notice, it is minus of half of the coefficient of x. And K is nothing but minus of half of the coefficient of y. Radius is h square plus k square minus the constant term. That's its square root of that. Now, let's understand this using an example. Find the center and the radius of the circle given to you as 2x square plus 2y square plus equal to 3x minus 5y plus 7. The first thing that I will do is I will take everything to one side. So first I've taken everything to one side, then I've divided throughout by 2 so that I don't have anything, the coefficient of x square and y square is 1. Once you've done that, now what you can do? You need to find the center. Center, we realized, is your h is minus half of coefficient of x. So it's going to be minus half of minus 3 by 2. So that's going to be 3 by 4. K is equal to minus half coefficient of y, which is equal to minus half, and coefficient of y is plus 5 by 2. So that's going to be minus 5 by 4. So your center is 3 by 4, comma, minus 5 by 4. That's your center. What's the radius? Radius, as I mentioned, is the square root of h square plus k square minus the constant term. So it's going to be square root of 9 by 16 plus 25 by 16 minus the constant term. Now, what's your constant term? The constant term is 7 by minus of 7 by 2. So minus minus plus 7 by 2. You will have to take the LCM, and that's going to give you 9 plus 25 plus 56. 7 multiplied by 8 and 16 here. So 4, of course, can come out. It's going to be 3 root 10 upon 4. That's your radius. The extremely important from examination point of view is equation of a tangent to a circle. Now, what is a tangent? Tangent is a line. It's a straight line, right? It's a straight line. So what will be its form? It's going to be of the form y equals to mx plus c. If we want to find out equation of the tangent, that means I would require the value of this m and the value of this c, right? So you need m and c. How do we find it? Let's first find m. We know that we are dealing with a circle here. So we will have an equation of a circle, and m is the slope of the tangent, right? Let me take an example so that it will be more clear to us, instead of giving you just a general case. Find the equation of the tangent to a circle, say x square plus y square equals to 25 at the point 3, minus 4. So at the point 3, minus 4 means that this is a tangent to this circle at this particular point, which means if I am creating a circle with radius 5, center 0, 0, because this is what the equation given to you tells you x squared plus y squared equals to 25. Now, the tangent is at 3, 4. 3, 4 will lie somewhere here. X-axis value is 3 and y-axis value is -4. So 3, 4 is somewhere here. And we want to find what is the equation of this tangent, for which I need the slope of this tangent. I need the constant c. What I can see here is, if I take this point P, which has the coordinates 3, 4, from here, if I will join, I can create a perpendicular to the radius. This is a perpendicular from 3, -4 to the center, which is the radius. This is to the center. Now you have 2 points, O, which is your center, and P, which is a point here. You have coordinates for both these points. You have 0, 0 the center, and the coordinates for P, 3, -4. Given 2 coordinates like this, can you find out the slope of this line, which is perpendicular to the tangent? Yes, of course I can. 2-point slope formula. Change in change in y upon change in x, right? That's what you have to find out. The radius OP is the perpendicular to the tangent. Now, what is the gradient of OP or the slope of OP? It's change in y upon change in x. I'm calling it M1. You've got 2 points. For OP, you have the coordinates of O, you have the coordinates of P. So 0, 0 and 3, -4. What is M1? Change in y. Change in y is -4 -0. Change in x is 3 -0. That means -4/3 is what you get as the slope of the perpendicular that you have, the perpendicular to the tangent. Now, if 2 lines are perpendicular to each other, do you know the relation between the slopes? Yes. M1 into M2 will be equal to -1, right? The condition of orthogonality. Since tangent is perpendicular to OP, that means the slope of the tangent is M and the slope of the perpendicular is M1. This should give you, the product should give you -1, which means M is nothing but -1 upon M1, which will give you 3/4. So the slope of the tangent with this method you have figured out, it is 3/4. Great. Once you have the slope of the tangent, you can clearly figure out the equation. Why? Because I wanted to know what is M. I have M. Now I need C. Once I have C, then I can easily create y equals to mx plus c. How will you find C? Now this point, 3, -4, it lies on the tangent, right? It lies on this. And I have M. So I know y equals to mx plus c. And I have x and y to put in this equation. If I do that, I know M, I have x and y. When I will put it, I can figure out what C is. So let's do that. 3, -4 lies on y equals to mx plus c, which basically means that -4 is equal to 3/4 into 3 plus c. And that's going to give you C equals to, therefore, now that you have your C, which is equal to -25/4 after the calculations, y is equal to M, that is 3/4, x minus 25/4. So you can say that you have the equation of the tangent is 3x minus 4y is equal to 25. Let's check if you've understood this concept or not. This time, let's take the equation of the circle as x squared plus y squared minus 6x minus 2y plus 2 equals to 0 and find the tangent at the point 1, -1. I want you to pause right now and try this out yourself. You require the center, you have the point, use the methodology that we have used just before this question, okay? Now let me show you the working. So we have the general equation x squared plus y squared plus 2gx plus 2fy plus c equals to 0. That's the general equation of a circle, right? We know that the center h comma k is minus g comma minus f. Okay. So clearly the center for us will be, since you have minus 6x here, so negative of half of this. So that's 3 and 1 coefficient of y, negative half of that. Okay, so 1. So 3 comma 1 is the center. Do not forget this. Okay, this is the simple way of remembering it. Clearly that means my circle would look like, or the equation of the circle will look like x minus 3 square plus y minus 1 square equal to r square a square, whatever is your radius, square of that. Okay. Radius also we know what it would be. Radius is square root of h square plus k square minus the constant term. So what you can do is you can easily figure out r square. R square turns out to be 8. How? Because 3 square gives you 9, 1 square gives you 1, minus 2. The constant is 2, as you can see here. So minus 2, that will give you 8. So r square is 8, mind you. R square is 8. This is the equation of the circle that we have into consideration. Okay. Now that you have the center, M1, let's take that as slope of the perpendicular to the tangent at 1 minus 1. So M1 will be change in y upon change in x, just the way we figured it out. You have 2 points. Your center is 3 comma 1, and your other point where you have the tangent point of tangency is 1 comma minus 1. So change in y is 1 minus 3 upon change in x is minus 1 minus 1. So this gives you minus 2 upon minus 2. That gives you 1. So M1 is 1. If the slope of the perpendicular to the tangent is 1, by the rule of orthogonality, I know that the slope of the tangent will be equal to minus 1 upon M1. That is, it's going to be minus 1. So slope of the tangent is minus 1. Now the tangent y is, the equation of the tangent is y equals to mx plus c, and 1 comma minus 1 lies on it. Since 1 comma minus 1 lies on it, I can find out c. I have m already. So c is turning out to be 0. And how? See, your y is minus 1 equals to m is minus 1 into 1 for x plus c. Minus 1 cancels out. You get c equals to 0. So if c is equal to 0, that means y equals to mx plus c will be y equals to minus x plus 0, which means the equation of the tangent is actually x plus y equals to 0. Okay? That's the equation of the tangent. The next thing that I want to discuss with you in geometry is parabola. Now, what is parabola? Parabola is actually locus of a point which moves in a plane such that its distance from a fixed point, which is called the focus, is always equal to its distance from a fixed straight line, which is called the directrix. So the scenario looks something of this sort. Suppose this is your S and this is the point P, which has the coordinates x comma y. And this point A is actually the origin. Now this line that you see here parallel to the y-axis, this is your directrix in this case. So MZ is actually the directrix. S is the focus that you have. S is the focus. A is 0, 0. And the length AS will be same as the length ZA. Okay. Now let's call that length A. AS is equal to AZ. And let's call it A, and A is positive. So what do we know by distance formulas? What we can find out, we have point P with us, we have point S with us. We can find out the length of PS. So PS or SP, that's going to be equal to, by the distance formula, it's going to be equal to square root of x minus a whole square plus y minus 0 whole square. That is, it's going to be square root of x minus a whole square plus y square. Let's keep it aside. Now, PM is equal to Zn, as you can see here. PM, this length is equal to this length that you can see here, right? Now, PM is equal to Zn, and Zn is actually equal to AZ plus AN, as you can see here. Zn is, let me change the color, this much amount, and then AN, okay? Now, this is A. You know that this is A, right? And AN is basically this much amount, this much length, and this length is nothing but X, because this point here that you can see here is X comma Y, which means this much length is Y and this much length is X, since this is the Y axis. Okay, so that means Zn or MP, they're both equal, they're equal to A plus X. And what now you can see is that by the definition of a parabola, for a parabola, your SP should be equal to PM. That's what it basically means, locus. So your SP should be equal to PM. And that is why you get your equation as SP square is equal to PM square. So getting rid of the square roots, you will get X minus A square plus Y square equals to A plus X whole square. And when you will solve it, things cancel out. As you can see, you have X minus A square here. Here you have A plus X whole square. So A square, X squares will cancel off and you will be left with just 4AX. That's how you get the equation of the parabola. So this is the equation of the parabola whose vertex is 0, 0. As you can see, the vertex is 0, 0. Now, I am interested in again figuring out some relation of the parabola with the tangent at a particular point. So equation of tangent of a parabola, say y square equals to 4AX. Again, the concept remains the same. Equation of a tangent, that's a straight line, so it will be y equals to mx plus c. Okay. Now, few points. Y equals to mx plus c is a tangent to y square equals to 4AX if c is a by m. So a is here and m is here. So if c is a by m, then y is equal to mx is a tangent to y square equals to 4AX. Let me just find out few things for you. We have y square equals to 4AX. So if I differentiate on both the sides, I'm going to get 2y dy by dx is equal to 4a, right? That's the first thing that I will get. With this, I can actually figure out dy by dx. And dy by dx is nothing but the slope m, right? So dy by dx is 2a upon y. Suppose the tangent is at the point x1, y1. So that means dy by dx will become 2a upon y1. Or in other words, m, your slope m of that equation will become 2a upon y1. Equation of a line passing through x1, y1 is y minus y1 equal to m times x minus x1. Okay, that's the equation of the line passing through some one point x1, y1. We know what m is. So that means equation of this line becomes y minus y1 is equal to 2a upon y1 into x minus x1. If you take y1 to the other side, take the LCM, that's what you will get. You will get y by 1 minus y1 square is equal to 2ax minus 2ax1. I can take 2a common also, of course. Now, what do I know? This point, since I have the tangent at this point, okay, your tangent is at this point. Whatever line you're talking about, x1, x1, y1. It's actually lying on the parabola also, because you have a tangent at this point, right? So it lies on the parabola as well. So it lies on the parabola. That means y1 square will be equal to 4ax1. So that is why you can convert y1 square to 4ax1. Once you've done that, then it's very easy. You can take all the x terms together. So that's what I've done. So combining this and this term, you will get 2ax plus 2ax1 on the right hand side. So y into y1 is equal to 2a into x plus x1. And that becomes your equation. That's the solution to the problem. This is the equation for the tangent. Let me take another kind of example now. Suppose this time y square is equal to 12x. What is the equation of the tangent drawn from -1, 2? I will repeat myself. Drawn from -1, 2. We are in this question not saying that the tangency is happening at -1, 2. No, we are talking about a point from where I'm drawing the tangent to this parabola. So both the things are different. The previous question was a general form, was a different thing. This is a different thing. Okay. So we have a point, particular point. This time we have a particular parabola. Let's work it out. Now I would like to see this parabola in my general form, which is y square equals to 4ax. 12x, that means I can write it down as 4 into 3x. So a is basically 3. I could figure it out from here. A is 3. Once I know that, let's again talk about dy by dx here. So 2y dy by dx is equal to 12. So which means dy by dx is 6 upon y. Dy by dx is 6 upon y. Okay, let's keep this aside. Now, equation of the tangent is y equals to mx plus c of like any line, like any other line. Now, the tangency is not happening at -1, 2. But what do I know? I know that I'm making a tangent from this point -1, 2. That means -1, 2 lies on the tangent. So since -1, 2 lies on this tangent, it will satisfy this equation, right? So which means that I'm going to get, after putting in x and y, I'm going to get 2 is equal to -m plus c. All I've done is I've put x as -1 and y as 2. Now for tangency, I remember I just mentioned in the beginning, c has to be a upon m, which means in our case, it will be equal to 3 upon m. So c is equal to 3 upon m, and I have this relation. Combining the two, what do I get? I get that 2 is equal to -m plus 3 upon m. Now taking LCM and solving. Let's take the LCM. You will get 2m is equal to -m square plus 3. Let me create a quadratic. M square plus 2m minus 3 equals to 0. Taking everything to one side. I think I can factorize this. I can factorize this. You have -3 here. You have 2m here. So you can take 3 and -1. So the two factors that you will get is m plus 3 into m minus 1 equals to 0, which means m could be -3 or m could be 1. So m could be -3, m could be 1. Hence the possible tangents are, you already have c, now you have two values for m, you can figure out the two tangents possible. Y is equal to -3x plus 3 upon -3. Don't forget, you have particular m. So I am taking m here as -3. When I take m as -3, this is what I get. And the equation looks like y is equal to -3x plus 1. Or you can take everything to one side also and say that it looks like 3x plus y plus 1 equals to 0. Or else if you take m equals to 1, y will be equal to x plus 3 upon 1. Don't forget, we are putting in for c a upon m. So that means y is equal to x plus 3, or you can take everything to one side and say that it looks like x minus y plus 3 equals to 0. So this was a different case, okay? We did not have the point of tangency, but we instead had that the tangent is coming from a particular point. That's also another kind of question that could be asked. Next quick brush up that I want to do with you guys today is the basic trigonometry. Now, what is trigonometry? Trigonometry is basically measurements associated to a triangle. That's why, you create a triangle, you have base, perpendicular, hypotenuse, and then you have all these thetas, sine theta, cosine theta, and so on and so forth, and results associated to them. So I'm just going to brush up few of the results with you guys, the basic ones, which you must know for when you're sitting for any of these entrances. So suppose you have a right angled triangle ABC, it's right angled at B. So this BC is your base, AB is the perpendicular, and AC is your hypotenuse. And the angle opposite to the 90 degree is, say, theta. In that scenario, few basic things that you should know. I just mentioned it in the beginning as well. Sine theta is perpendicular upon hypotenuse. Cos theta is base upon hypotenuse. Tan theta is perpendicular upon base. Cot theta is 1 upon tan theta. Cot theta is 1 upon tan theta, so automatically it will be base upon perpendicular. Secant theta, sec theta means secant theta. Secant theta is 1 upon cos theta, so it will automatically be hypotenuse upon base. Cosecant theta is 1 upon sine theta, so it will be hypotenuse upon perpendicular. So these are the basic things that you should know, the ratios. Then what else you should know? You should know the basic values. When theta is 0, 0 degree, 30 degree, 45, 60, 90, 180, 270, 360. That is till 2 pi. You should know what the value of sine theta would be, cos theta would be, tan theta would be. Automatically, you can find out for cosec, sec, and cot. So sine theta would be, it starts with at 0, it's 0. Then 1 upon 2, then 1 upon root 2, root 3 upon 2. At 90, it is 1. And cos theta at 0 is 1, and at 90, it is 0. Sine 180 is 0. And cos 180 is minus 1. Sine 270, that is adding 90 to 180, you will get minus 1, is a negative quadrant. And then 360 again, you will get 0. For cos, it starts with minus 1, then you have root 3 by 2. It goes opposite basically. So root 3 by 2, 1 upon root 2. So cos theta and sine theta are equal at 45 degree. That's another important thing. And because of which tan theta, since tan theta is actually just the ratio of sine theta and cos theta, you will get 1. Now, cos theta is half at 60. Then at 90, it is 0. As I said, at 180, it is minus 1. At 270, it is 0. Then 360, it is 1. Tan theta is 0. At 0 because sine theta is 0. And at 30, it is 1 upon root 3. 45, it is 1. 60, it is root 3. At 90, it's not defined because the denominator becomes 0. Sine theta upon cos theta becomes 0. At 180, it is 0. At 270, it's not defined. At 360, it is 0, and so on and so forth. Cosec theta, since cosec is 1 upon sine theta, it is not defined at 0. Then you get 2, root 2. As you can see, these are just the reciprocals. So it's nothing but 1 upon sine theta. So just keep this in your head. Please keep this in your head. Okay. Now, this will be 1 upon root 3. The formulas that you must know. The formulas that you must know, sine square theta, the identities. Sine square theta plus cos square theta, no matter what theta is equal to 1. Tan square theta plus 1 is equal to secant square theta, or secant square theta minus tan square theta is equal to 1. Cot square theta plus 1 is equal to, just in the similar manner, cosec square theta. Okay. 3 identities and some more actually. Also, the ratio identity. So suppose you have a triangle like this. Suppose you have a triangle like this. So you have ABC triangle. If you have ABC triangle, and we will take the triangle sides as opposite to the angle. So if B is here, the right opposite, the length we will take lowercase b. If C, the angle is here, then right opposite you will take lowercase c. A is there, so I'm taking lowercase a here. So the sine ratio formula is A upon sine A is equal to B upon sine B is equal to C upon sine C. This will always hold true in any triangle. Then also what you should know is sine of minus theta, cos of minus theta. What happens to that? Sine of minus theta is minus sine theta, remember. Cos of minus theta is cos theta itself. Tan of minus theta is minus tan theta. Cosec of minus theta works like sine, so minus cosec theta. Secant of minus theta is secant theta, works like cos. Cot of minus theta works like tan. It's going to be minus cot theta. Apart from that, you should know sine A plus B. If you add two angles, sine A plus B is sine A cos B plus cos A sine B. Sine A minus B will be sine A cos B minus cos A sine B. Cos A plus B will be cos A cos B minus sine A sine B, and cos of A minus B will be cos A cos B plus sine A sine B. How can you use it? It's very simple. In case you have to say find out cos of 105 degree. So it's easy to break it in terms that you are aware of. You are aware of 60 and 45 for cos. So you can break it as cos of 60 plus 45, and now you can use the formula. Apart from other cases where you do use these identities whenever required. So this you can break and find the value cos 60 into cos 45 minus sine 60 into sine 45. You know the values of cos 60, cos 45, sine 60, sine 45. Just put the values in and you can find out cos of 105 degrees. It will turn out to be 1 upon 4 into square root of 2 minus square root of 6. What is important for you, and I'm giving you this as a homework. I'm sure you must be working at your end. And as I said yesterday, please do at least couple of questions around these concepts, because these are the basic concepts around which you could be asked questions. You should find out, using these identities, try to find out sine 2 theta, cos 2 theta, sine theta by 2, cos theta by 2. Please try to find out. These are also important identities. Apart from that, tan. Let's not forget about tan. So tan A plus B is tan A plus tan B upon 1 minus tan A tan B. And tan A minus B is tan A minus tan B upon 1 plus tan A tan B. So always remember these formulas. Also important for you to remember, cos 90 minus theta gives you sine theta. Sine 90 minus theta gives you cos theta. Tan 90 minus theta gives you cot theta. Okay. This is what I wanted to discuss in today's lecture. One more basic lecture I will take up, before your entrance, because I would like to discuss some more concepts which could be asked in your exams. All the best, all the times. Thank you.